Where is gravity strongest on Earth?
All right, so if we cut to my screen on here, I actually had this question fed to me beforehand, and I set everything sort of up. So if you look at my little makeshift diagram of what the Earth is like, you'll note that the Earth is always spinning. And so you might look at it and you might think, oh, it looks fairly uniform all around, because gravity is simply a force that pulls everything towards the center. And so you might be sitting back and thinking, it's fairly uniform all around. What would be the difference? Well, first off, it's actually a little flatter at the poles and a little bulging at the equator. And so you might be sitting back and thinking, well, that must have a huge influence on it. Actually, that's not the answer for it. The answer actually has to do with circles. So as I said, the Earth is constantly spinning, and it spins fastest at the equator. You might sort of think of, say, a record. If the record is spinning and you're looking at its spin, and then you notice that it's spinning, it has the same revolutions per second on the edge as it does in the center. However, it's traveling a lot less in the center, and you can do that by simply taking like a measure and measuring how much it moves in the center and how much it measures on the outside. And that's because even though it's moving at the same the same rate, it's actually moving a lot faster on the outside. And so you might sort of think about, well, what does that have to do with Earth? I'm pretty sure I learned that the Earth is round, not flat like a record. Well, yeah. However, of course, if you sort of look at it from the top, you might notice that it's sort of similar with the record, as in it would be a lot less faster at the poles. That sounded weird. And a lot faster at the equator. And so when you look at this, you notice that whenever there's rotational frame of reference, there are two forces that are really interesting here. Those would be the centripetal force and the centrifugal force. And so you might be thinking, what's the difference between those? The centripetal force, as I've been taught to sort of think about it, would be like the petals of a flower. It always goes in. And so you might always want to look at PET, always to remind you petals of a flower always goes in. So it always pulls everything towards the inside, towards the center of the circle. And then you sort of think about the centrifugal force, which I've always been taught to think about the root there like fugitive. It's something that's trying to get away. And so it's trying to get away from the center of the circle. And you're sitting back and thinking, why are you telling me this, Luigi? This is useless. Doesn't answer gravity. Well, sort of does. As I said, you just need to think about gravity as a force that's pulling down towards the center. And it's pulling towards the center of the Earth, much like our centripetal force would here. The centrifugal force is greater near the equator, and so it's trying to pull things away from the Earth. And so therefore, you actually have just slightly less gravity there because of that influence of the spin. And as a matter of fact, sort of an interesting fact that I know about this, the reason we launch a lot of our rockets from Cape Canaveral is because it's closer to the equator, and therefore there's a little less gravity, just a little bit of a speed boost for whatever is coming out, a shuttle, a rocket, what have you. And so as a result, that's why they do it. All these engineers at NASA and everything have calculated these things and figured out if we want to get away from Earth, we want to be with the fugitives, we want to be with that centrifugal force, we want to get away. And so that's how you know that, of course, it's all going to be right down here in our makeshift equator. That's the place where the gravity would be the weakest, not necessarily because of any gravitational effects, simply because Earth is spinning, centrifugal force pushes you away from the Earth, so gravity loses the battle just a little bit, becomes a little weaker. So I hope that answered your question there.
Yeah, that's super cool.